how do we explain this? Friction is not what really helps us attain centripetal force here. It's not friction. What helps us to get centripetal force here, and centripetal force here, that keeps this whole thing in motion, is what we call normal work. It's normal force. Normal force or reactive force. Normal force or reactive. Normal force or reactive force equals to centripetal force. That's what we have, equal to centripetal force. So this whole thing at a given angle theta. So now don't forget there's a weight for this very body that goes this way. So, but you're not going to focus on that really. You're going to be focused on normal force. So there's a normal force like this. There's a normal force that goes like this. There's a normal force like this. Fm. So this normal force acts at a given angle against the horizontal. Although we have a weight acting down like this. There's a weight acting down like this. A weight acting across. I'm sorry for my diagram, but there's a weight acting down like this. Or we have a normal force acting. There's a normal force that keeps this body moving in the circular path. So this normal force is at angle theta against the horizontal. So for the fact that we have a normal force that goes like this, the normal force could be resolved in 2 dimensions. We have theta here. A normal force in 2 dimensions. Like this, and like this. So we have a normal force along the y-axis and normal force along the x-axis. This is the angle. So what do we have here? This opposite hypotenuse. So the normal force along x-axis is normal force times, what it is? Normal force times sine theta. That's that. And normal force along the y-axis is normal force times, what do we have? Normal force times, normal force times cos theta. So Katua, very important. Opposite hypotenuse, adjacent. Adjacent hypotenuse is cosine. So we have this set out. As simple as that. So what do we do next? What do we have next? Now let's compare. There's a direct weight from the center of this very car moving in a banked path like this. So when we have sum of forces along y-axis, which is mass and acceleration along y-axis, acceleration along y-axis is 0. There's no movement along y-axis. We know that. The sum of forces along y-axis is 0 Newton. There are no, all the forces along y-axis will cancel out each other because there's no movement along the y-axis. This is horizontal uniform circular motion. That's what we're discussing. So what are the forces we have? We have a normal force, the Fn, minus the direct weight. There's a direct weight here, Fw, equals to 0 Newton. So we have Fn minus gravity, mass times gravity, 0 Newton. So the normal force